Hello, this is Amanda Sage again for ISA 4220, Professor Green's class, spring semester 2017. I'll be going over both IMAP and DNS for Windows Server 2012 R2 and Ubuntu Server 16.04.1 LTS. All right, I'm going to start with talking a little bit about IMAP on a technical level. IMAP is the acronym for Internet Message Access Protocol. It allows a user to retrieve their email messages directly from the mail server. It actually has more capabilities than the POP server, and it does this by enabling the user to access the email from both a desktop and or a mobile device without losing the email to one of those various devices. POP does not allow such a diversified flexibility when accessing the server from separate devices, unlike the IMAP does. And what I mean by this is whenever you're downloading an email to your desktop and you're utilizing the POP server, you will proceed to try to look at that same email on your mobile device, and you won't be able to actually see it because it won't pull down to the mobile device. It has already been pulled down and downloaded to your desktop. Now, utilizing IMAP's protocol, you will be able to take that same exact email, download it to your desktop, and you'll also be able to go and look at it on your mobile device because it has not been lost to one or the other of the devices. Next thing, IMAP has a store and forward process, unlike its predecessor POP. And in regards to administering and maintaining the user's messages, IMAP gives the admin more capabilities in which allows them to perform their duties with ease. All right, now I'm going to review Dovecote. It supports the IMAP protocol. Dovecote is an open source email server that is used for Linux and Unix-based operating systems. It is one of the highest performing IMAP servers that are out there. The Dovecote email server supports the IMAP email protocol and controls incoming email transmissions. Dovecote really focuses on the presence of security within its email service, and it also stays standard compliant so that it may pass all IMAP server standard compliancy tests, which whenever you get into the big corporations, you got to be standard compliant. This program, it also offers a self-resolving program. In other words, if it detects a problem, it can sort it out all on its own and fix it all on its own, therefore saving corporations time and money, and anybody running Dovecote personally, it saves them time. And sometimes time is money. It also supports easy mitigation from existing IMAP servers. It is admin friendly by displaying easy to read and follow error messages. The program can be installed and used on a small or large scale. In other words, small businesses can use it. Someone can use it on a personal level with just one computer, or you can use it in a very, very large corporate setting. It is also easily extendable and has plugins that allow for new commands to be added, modification to existing behavior, and offers support for new mailbox formats. There are four main processes that Dovecote runs. The four main processes are master process, the login process, authentication process, and mail process. And in regards to master processes, this process makes sure that all processes run efficiently and successfully. In regards to the login process, it makes sure that the minimum requirements for POP3 are there, ran, and met. For the authentication process, it makes sure that all user credentials and passwords are up to par. And for mail processes, it is basically a post-login email management system. Alrighty, to harden the Dovecote server for IMAP protocols, you will want to first off always keep your system up to date. Always install all patches so it ensures the security of your system along with the network if you are working with an entire network. You want to open and enable protocols. You want to also configure your mailbox. You want to use port 993 for IMAP S. You can use IMAP 143, but it is not as secure as 993. If you use 143, it is actually used for unencrypted transmissions, whereas IMAP S the port 993 is used to encrypt your email transmissions. You want to enable SSL, which I have provided a few commands down there on how to enable SSL. And this is basically enabling the secure sockets layer to help further protect your email transmissions. You will also want to password protect your key file. I've also added a command in here for that as well. This will protect your password by using a key file. You also want to implement and configure certification and authentication certificates. This will allow you to even more further harden that Dovecot server, so your email transmissions can stay all encrypted and safe and secure. Alrighty, I'm going to review DNS in an all-around technical aspect. DNS is an acronym for Domain Name Service. DNS's job is to convert host name into IP addresses so that the user may be able to access a website on the internet. URLs are specifically designed for human use only. It is close to impossible for mankind to remember the billions of website IP addresses out there. IP addresses, on the other hand, are designed strictly for computers. DNS comes into play by converting the URL that the user types in into an IP address so that the user system may call out to that internet domain for a connection. For an organization with many departments, DNS namespaces are split up into zones within the DNS server. Each zone is typically dedicated to specific departments based on their size and relevance to one another. The DNS server can become what is called the authoritative name server if it withholds the files for a specific zone. A zone transfer is when a primary and secondary DNS sync their information. Most larger organizations will implement a primary and a secondary DNS. Two DNS servers are put into play just in case the primary DNS server fails. The secondary server can then come in and pick up where the primary DNS server left off so that daily operations will not come to a halt and everything can proceed as need be. The records that are housed within the DNS server are called resource records. Resource records map host names to their IP addresses. In regards to DNS and Internet DNS, when a DNS server struggles to locate a host name, it can call out to another DNS server on a higher level to help it find the requested host name. All computers have a DNS resolver built in so that it may assist in sending the DNS server the user's request. The DNS resolver sends out two types of queries. A non-recursive query has two functions. If the request is successful, it will go directly to the DNS for processing. If it is not successful, an error message will be returned back to the client. In a recursive query, which is the second query that the DNS resolver sends out, it will pass the user's request from one DNS server to the next until the request is successfully connected to its requested destination. All right, now I'm going to go over DNS in a technical aspect for both the Windows Server and Ubuntu servers. Windows offers the IIS approach, and Ubuntu offers the bind approach. IIS for Windows, it offers a modular approach for DNS installation so that the admin may pick and choose which services and features they want to configure into the DNS server. The ability for the admin to be able to perform the function prevents the DNS server from getting overloaded and bogged down with services it does not need. To set up a DNS server on the Windows Server 2012 R2, the user will need to first access Microsoft Windows Server Manager. Once in the Server Manager, the user will then be able to begin the DNS server installation process. This action can be completed by accessing the Add Roles and Features wizard option located in the Windows Server Manager. The user will then be prompted to select if the installation should be role-based or feature-based installation. The users will want to select the option if they are this option if they want to configure a single server. Once the Add Roles and Features wizard is configured, the user will then need to configure their DNS server by using the DNS server wizard. When in the DNS server wizard, the user will need to select either a forward lookup zone, a forward and reverse lookup zone, or root hints. It is recommended by the DNS server manager to use the following, forwarding lookup zones for smaller networks and to configure forward and reverse lookup zones for larger networks. The DNS server wizard advises to only use root hints if the user is a very advanced user. After this is completed, the user will then be prompted to create zones and allocate an IP address for forwarding queries. For Ubuntu Bind, it's actually a Linux-based program. In regards to DNS, Bind software was named after the University of California, Berkeley, and is an acronym for Berkeley Internet Name Domain. Bind is a transparent program, meaning that it is committed to providing a lucid service when it comes to structure, business practice, and design. Bind is also an open source DNS server that is compatible with Windows, Unix, and Linux-based systems. It is a full-featured and very flexible DNS server that is easy to modify and is aware of the features required to run almost all available applications. Bind is one of the oldest and most well-known DNS servers that is allocated to networks more than any other DNS server solution. Bind consists of three main parts. Those parts are Domain Name Resolver, the Domain Name Authority Server, and tools. Like Windows IIS, Bind offers the Domain Name Resolver and can offer both recursive and non-recursive queries. The difference between IIS and Bind is that the non-recursive queries are not set as default queries in the Bind program. If a user wants to implement non-recursive inquiries, they must configure, non-recursive queries, they must configure it into the Bind server itself. Bind also possesses a domain name authority server. This server responds to requests that are sent from the resolver. It also offers a variety of tools for operations and diagnostics. All right, now I'm going to go over DNS hardening for Windows IIS and for Ubuntu Bind. First, the user will want to ensure that Windows IIS has been previously hardened to aid in securing their DNS. Then the user will want to utilize the Best Practices Analyzer to review and repair any loose ends that need to be wrapped up on the DNS server. I'm going to already say I've been configuring my Windows DNS server already in our little environment we have. And definitely the Best Practices Analyzer has helped out a whole lot in figuring out what's wrong and what I'm doing wrong. The user should determine what security threats their DNS server faces based on their environment. This will allow the user to determine the level of security that must be implemented to further protect their environment. In other words, the user doesn't want to depending on what their environment is, they don't want to have light security, but also they don't want to lock everything up so tight that nobody can use anything. An organization should try to implement an internal DNS server and an external DNS server so that it may prevent anyone from outside the organization from accessing and acquiring internal system information. If using multiple DNS servers, the DNS server or servers that endure internet exposure should be configured with restricted zone transfers. The restricted zone transfer should identify the DNS server either by zone or by specific DNS within the network. The DNS server should be configured to listen to specific addresses that are allowed. It should also if the user wants to, they will want to, or excuse me, the user will need to confirm the server's default cache security options. Make sure that they are chosen so that it can protect the DNS server from name pollution. To ensure that only authenticated users can access the DNS server, secure dynamic updates should be allowed and implemented. This will aid in preventing an attacker from obtaining trusted hosts' IP addresses. Therefore, whenever the attacker doesn't get the IP addresses, that means they don't get into the network via the DNS. Internal DNS servers should be configured with root hints that point to the internal root domain only. Root hints should never be pointed to an external DNS server that has direct access to the internet. And this only further hardens and secures your DNS server. Active Directory access control lists should be utilized to secure the DNS server by controlling who has access to the DNS server service. You want to also use Active Directory DS, integrated DNS zones, so that these zones can utilize the security features that are offered by the Active Directory. This can be accomplished by modifying the DNS zone file. Next, I'm going to go over binds, hardening processes. Bind should only be running on a dedicated DNS server. If bind is running on a DNS server alone, it will reduce the risk of other services interfering with its operations. If another service is under attack, then DNS will stay safe without interruption. You want to also utilize the access controls feature so that recursive queries can be restricted to permitted users only. DNS servers that are facing the internet should not have recursive queries dedicated to them at all. This will help further secure the internal DNS server and the entire network. It is also good to run hidden primary masters in the case a zone becomes overloaded. It will not have a negative effect on the resolver or query process. You will want to run multiple servers. You want to use a primary and secondary server, just like stated before earlier in the presentation. Whenever the primary server goes down, the secondary server can come up and pick up where it left off, and it will not interrupt daily operations. Like most programs, the user will not want to run this program as a root. Root can become very disastrous when the user does not know how to utilize it, and to prevent disaster, it is just best to run as a sudo user. Finally, always keep the system up to date so that all patches are downloaded, and in turn, this further protects your system, your DNS server, and your network as a whole.